So part B of this, we're going to generalize that f of n plus f of n plus f of 1 over n is going to be equal to 1. So again, we want to make sure that we recognize that there is this outside f function. So we have our f function, we defined it as x over 1 plus x. And then the same f function is going to be x over 1 plus x. So both f's are the same. What's different in those two expressions is, in this one we are putting n in, and in this one we are putting 1 over n into the expression. Okay, so we've now done our f of x substitution. We've applied function notation. We just need to simplify this. So to simplify this, what I'm going to do first is I want to get rid of the divide by n over here and over here. I want to get rid of those divide by n's. So to get rid of divide by n, I'm going to multiply by n on the top and bottom. That balances my fraction, and furthermore, that will get rid of my n. So on the left-hand side, I get n over 1 plus n, plus, when I multiply through by n, I end up with just 1 in the numerator. N times 1 is n, plus 1 over n times n is 1. And so when I rearrange this, I'm just going to make it look a little bit nicer. It's going to be n over n plus 1, and then 1 over n plus 1. They have a common denominator. So in the numerator, I'm going to add the numerator, n plus 1 over n plus 1, and that will be equal to 1. And so for any n value, it's going to be equal to 1. And that kind of then justifies what we got here and here. For 2 and 1/2, 3 and 1/3, n and 1 over n, we will always get 1 because of the way that it simplifies algebraically.